Assalamualaikum warahmatullahi wabarakatuh. Berjumpa lagi for part 2 lessons 06 week 7. Okay, for displaying data from multiple tables. Okay, so let's start straightforward and jump into the slides number 20 for our next lessons agenda here. Okay, so let's start from the current slides. Okay, so for part 2, we are going to look into self joints, non-equi joints, outer joints, and also a Cartesian products. Okay, so let's start without further ado. Let's start with the self joints. Okay, so for the next lessons, alright, so joining a tables to itself. Alright, so before this, we try to join from two tables, multiple tables, 2 or 3 tables. So for this part, okay, continue with the joining a table to itself. So meaning that we join tables based on one table only. So the only table here is employees, but so we can virtually join these tables to itself. So this is what we call as a joining a table to itself. Okay, so in these examples, manager ID in the worker tables is equal to employee ID in the manager tables. Okay, we try to virtually divided this table into 2 different tables. Okay, number 1 is call it as a worker, and number 2 is we call it as a manager. But actually this is come from one table, name says employee. Okay, so this is what we call joining a table to itself. Okay, so let's move to the next slides. Okay, so in these examples, when we self joins using the on clause, okay, the on clause can also be used to join columns that have different names. Okay, columns have different names. So the previous one, we must make sure that the columns have same names. If let's say in table A we have department ID, in table B we also have a department ID. Both column is same names. But in this situation, we can use on to join the columns that have different names. Okay, so within the same table or in a different table. So sama ada dalam table tersebut ataupun in the different tables. Okay, the example shown is a self joins on the employee table based on the employee ID and also manager ID. So this is column number 1, call it as an employee ID. This is another column, call it as a manager ID. So both column here have a different names. Right, so this is what we call self joins. Okay, so for example here, okay, listen carefully. Right, select a worker. Okay, select worker last name. Okay, so meaning that these columns come from tables names as a worker, and here is a column alias. We simplify the column names to EMP, and then after that we have a column names last name comes from tables manager. Alright, and column alias that columns as a MGR. Okay, so where is the worker and also the manager comes from? Alright, so that is why from employees, okay, this is the original table, this is also employees, but for these tables, okay, like the previous one, we virtually create the worker table based on the employee tables, and also we create a manager table based on the employees tables. Okay, so this manager come from here, and this worker comes from here. So it's actually we have only one table. Okay, table names as employee, but we try to separate the the tables. Okay, number 1 is worker. Okay, number 2 is manager. Okay, so that is the situations. Okay, so on. Okay, so in this case we are going to use the on clause here. Okay, on worker. So worker comes from here, and also manager comes from here. Okay, using these two different column name. Number 1 is manager ID, number 2 is employee ID. So this is what we call as, we can use to join column that have a different names. Okay, names number 1 is manager ID, name number 2 is employee ID. So in these situations, okay, we can use both names, different names for joining the tables. Okay. Alright. So hopefully you can understand. Alright. So hopefully you can understand. Alright. So the next one is, if let's say you see here, you can see here, the parentheses around the joins column, as in the example. Parentheses mean bracket ni. Okay, this is what we call as a parenthesis. The bracket is optional. So meaning that this is optional. Okay, either you want to put a bracket, or we call it as a parenthesis, or without parenthesis. Okay, this is just an optional. So even on e-manager ID, okay, it will work. Okay, meaning that with or without the parenthesis. Okay, so the outputs for these tables is employee is number 1 because this is come from here, MGR come from here, and the column alias, and this is all the data. So meaning that this employee is the manager of this employee is this one. Okay, so Faye is the employee and the manager is Hartstein. Right, so this is manager, this is employee, this is manager, this is employee. But these people come from the same tables. We call it as an employee. So that's why this is what we call a self-join using the on clause. Okay, so let's move to the next one. Okay, non-equi join. Okay, the next one is non-equi join. So we have, before this we have a natural join, and we have using on self-join, and this is non-equi join. Okay, so for the non-equi joins, we can use this to join tables even there is no matching column. Even there is no matching column. Alright. So if let's say we have one table names as employee and another one is job grades. So we want to join two different columns. Okay, so the column number 1 is salary, and then the other column is lowest salary and also highest salary. So all these column names is not matching. It's not going to be the same, and it's not matching. So in this situation also we can join the table. So when we join and we want to join this kind of situation, this is what we call as a non-equi join. So non-equi joins is even no matching columns. Okay, so say for example, alright, so job grades tables defines the lowest salary and also the highest salary range here of value for each grade level. Hence, the grade level column can be used to assign grade to each employees. Okay, we can use this column, okay, grade, to assign the grade to this salary. So we have job grades here. So we in this situation we can know that if let's say they have the salary is 24,000, okay, this is grade level A, B, C, or D. So something like that. Okay, so let's move to the next slides. Okay, so in these situations, select E last name. All right, E last name. Select E salary. Select J grade. Okay, from employee. All right, so and then we make it a table alias here, E. Join the job grades here. All right, so table alias to J. So straightforward, we can know that these columns come from table employee, these columns come from table employee, and these columns come from tables job grades. Okay, and we are using the on clause. Okay, salary meaning that this is come from table employee between right, lowest salary and also higher salary both come from table J. J means job grades, and automatically we can see the output here. So each salary here we have a different job grades. Okay, so in this situation we can also retrieve records even though the column names for both table is not matching. So this is what we call as a non-equi joins. Okay, so hopefully you can understand. If let's say just be confused or whatever, just look carefully, go step by step, one by one, and then you can realize. So meaning that for these situations, if let's say we have two different column names, even there is no matching in the column names, we can still retrieve the records. Okay, so we can still retrieve the record here, like these examples. Okay, let's move to the next one. Okay, so forget about the error here. So error because in our original table there is no grade level. Okay, never mind. Okay, this is just an example. Okay. Alright, so retrieving records with the non-equi join. Right, so of course the error previously is because there's no tables names as job grades. Okay, so if let's say you want to try these examples, you need to create this table first, right? Create table as also column job grades, grade levels, lowest, and also highest level. Okay, but then it doesn't matter. You just wait until the next lesson, and when we talk about data definition language, DDL. Right. So we can add the rows here, and also at the end of the day we can create the syntax, same as this one. Alright. Okay, so this one. Alright. So the example is quite clear. Alright. So for the next lessons, alright. So this is what we call as outer join. Outer join. So we can use left, right, and also full join. Okay, let's move to the next slides. Okay, returning records with no direct match with outer join. Right. So we can use joins with a no direct match, and that we call it as an outer joins. Okay. In this example, right? So we have two tables here, departments and also employees. Okay. All right. Number one is that there are no employees in department 190. Okay, so in this example, there are no employees in department 190. Okay, so we have one department here, contracting. Okay, and the department ID is 190, but based on the data here, okay, there's no employee in this department. Okay, so there's in this situation, we call it as there is no direct match with the records. Okay, so we can find also this department, even though there is no employees inside the department. Okay, so let's move to the next one. Okay, in SQL 1999, the joins of two tables returning only match row is called inner join. Okay, number one, call it as inner join. A join between two tables that return the result of the inner join as well as the unmatched rows from the left or right tables is called the outer join. Okay, so this one inner join, and the one is outer join, and the next one is a join between two tables that return the inner join as well as the left and right join is called it as a full outer join. So we have three different join: inner, outer, and also full outer join. Okay. Next. Alright, so for this example, this query retrieve all rows in the employee table, which is the left tables. Okay, so the left table, even there is no match in the departments tables. Okay, in this situation previously, there is no employees in the departments 190. Right, so there is no match table. Okay, so what we're going to do? Okay, we can use the outer join. Okay, so this is the example. Select last name, department ID, department names from employee. Alright, so we have one tables employee, another tables is department. Alright, so this is the tables layers. So we know that in this department there is no employee, so you're going to use the words left outer join to find the departments that is 190, because the department have no employee. So on department ID, okay, the same, using the same column names, the same names, department ID and department ID. But then we can look that in these examples. Okay, so grant, we have a last name here, department ID here, and also department. So when we talk about left, so in this table department, there is no department ID. Okay, grant is not in the department ID. So one is left. Okay, so we can turn it around. Okay, we can use left outer joins. Okay, in these examples. Okay, so the query retrieve all rows in the department tables, which is the right tables, even there is no match in the employee tables. Okay, mean that, okay, this is the example number one. They have a department number 990, but in this department there is no employee. So how we can find this information? So we can use the right outer join here. Okay, so how? Okay, so we select the last name, department as usual, department names from employees. Okay, E join with the department using the right outer join. So right is here, department. So right means department. We have a department 190, but there is no employee inside that department. On department ID and also department ID. So that's why the result is something like this. Okay, we have a department 190 that is contracting, but there is no employee here. Okay, compared to the previous one. Okay, the previous one we have employee. Okay, we have employee here, but the employee is not in any department. Okay, so that's the difference. Okay, sometimes we have staff, but the staff is not. We not put that staff in any department, in our department, in our organizations. Okay, but in this situation, there's two different things. Okay, either there is left or there is right. Okay, so let's move to the next one. Okay, if let's say you want to retrieve both left and also right, okay, in these situations, I said that the query retrieves all rows in the employee table, even there is no match in the department tables. It also retrieve all rows in the department tables, even there is no match in the employee table. So in this situation, we can use full outer join. So full outer join will find both, from the left or from the right. This is right, this is left. Okay, so meaning that there's department here, but there's no employee, but we have employee here and there's no department for this employee. Okay, something like that. So just to be safe, better just put full outer join instead of left and also right, so we can find both information straightforward. Okay, so let's move to the next one. I think, right, so finish with the outer joints. Okay, the last one is a Cartesian products. Okay, this is quite simple for the Cartesian product. Okay, Cartesian products is a form when a joint condition is omitted, a joint condition is invalid. Okay, if let's say there's no all the rules of the joints is invalid, omitted. Okay, all rows in the first table are joints to the rows in the second tables. Okay, to avoid Cartesian product, always include a valid joints conditions. Okay, it's quite simple. Okay, so for this one, let's say for example, generating a Cartesian product. Okay, if let's say in this table employees we have 20 rows, and for department table we have 8 rows. So for the Cartesian product, it will multiply all the rows from the employees 20, and also all the rows from the department 8, and the output is 160 rows. So we can have here so 160 rows. So it will just multiply the table. So remember, if let's say we have more rows, please be careful with the Cartesian products here. Okay, the syntax is very simple here. Okay, the syntax is very simple. We just need to use the words cross join. Okay, the cross join clause produce the cross product of two tables. This is also called a Cartesian product between two tables. Okay, it's just quite simple. Okay, just put a cross join. So before this, we put natural join, non-equi join, and so on. But for this one, just put cross join. Okay, so they will cross the rows from both tables. Okay, so we can have the output something like this. Okay, right. So I think that's it for part 2. Right. So for the summary, we already learns about how to join a table even though it is a self-join table, like this example. Okay, or maybe equi-join from multiple tables, 1 or 2, 2 or 3, outer join, self-joins, cross-join, natural join, and full outer joins. Either it is left or right. Okay, so with that, I think finish for this chapter. Okay, so thank you very much. I hope I can see you again in our next lessons, lesson 07 for week 8. So with that, thank you very much. Assalamualaikum warahmatullahi taala wabarakatuh.